Welcome back. We're on Proposition 32, and with a little bit of application and very simple understanding of what's going on. Proposition 31's very simple. It's basically taking a triangle, and if one of the sides is reproduced, at angle, the external angle equals the same as the two internal opposite angles, and basically says that the internal angles of a triangle are equal to two right angles. So applying that with a little bit of ranges and a little bit of playfulness, you can have a little default here. Even this manipulation of these objects, think of the complexities of building something that's so commonly done, spiral staircases, but with total beautiful parametric control. Of course, this can be mirrored and this can be rotated and pushed to the negatives, but all of my number sliders are staying basically around -1 to 1, which is it's going to allow for great jumping into trigonometry. But you can see what's happening here is I just bring that rotation up and bring that count down. I have a lot of control, and if I want to just leave this as a unit of 0, let's say, and bypass this whole range that's coming in here and just have this number multiply into here directly. You see without that range you still have a lot of finesse over what you can do. You can see the top view and see the 3D model or perspective view of what's going on. Really nice. And actually I think what I'm going to do for the sake of making this more interesting, set view, let's go to isometric. I think that's going to actually let's go to this view. Yeah, I think isometric is going to make for more interesting diagrams and engineered or architectural drawing diagrams. I think I'm going to use that just so we don't confuse things a little bit through perspective. So that's a shift I'm going to make going into Grasshopper 2. I'm going to also run that line back into here, and you can see the symmetry that appears on each side. So you can balance out this really beautiful form by possibly snapping right to 0. And if you're going to snap anything, just give yourself something, because I think the number snaps are gone, and that was going from here to 1. So I can bring that one down to 0 as a beginning, and then I can push that one through the rotation, put a gorgeous pattern. And I think I'll just jump into the top view for that so you can understand the complexity. So what's going on there? Really nice pattern that's also a 3D model. And this is taken from very simple Proposition 31. And my models are fairly consistent. I'm not using anything too tricky. I'm certainly not diving into tree data as much as I was before, the metas, or getting in statistics and all these special nodes. Keep it simple to start. Make yourself some beautiful models. Build up an inventory of what you can actually draw as architectural forms and understandings. And there you go. You're able to play off of weighing things one way or the other and having some pretty playful things. If you're into symmetry, you can keep it that way, but I actually am one that thinks symmetry is fairly simple, and it's best to I think I can overlap these, which is kind of interesting. So let your number sliders happen. Let's watch what happens to this isometric model as we go into it. And I have to adjust my eyes to isometric because I'm so used to the other thing. Let's just go over here and take a look at this. Let's push this one back from 1 to -1. Now let's see what happens. -1 as a model. Let's pull that one back. There you go. That's how you can put that mirrored. So just a simple little number transformation of mirroring that one through the bottom and through the top. And then you can also, and that's going to be a nice range. So really nice model that I just figured out, playing around with simple number sliders. So there's so much you can do with these scripts on the most basic level of just understanding the propositions of Euclid's Book 1 in Elements. Thanks for watching. Michael Wickerson at Wickerson Studios. If you want the files, they're all available on my GitHub. I don't think I have them on private yet, but I will start to make these private as we get more and more complex. But right now, it's the basics and trying to get people hooked on G2, Grasshopper 2, and getting hooked on geometry again. Very basics of it, and its applications to engineering, architecture, artwork, creation, design, or anything. Thanks for watching.